Okay, hi. Alright, so now we are in new video, right? So in this video I will proceed with the example 2. Okay, example 2. So the previous video we already done the example 1. I already show you how to answer, how the steps to answer for the series. Okay, so for the previous video the function is odd function. Okay, alright, so now for example 2. Okay, so the question asks you to compute the Fourier series for the function given here is modulus x. Okay, modulus x with the interval -1, 1. Okay, so clearly that you can get your L from this interval. Alright, so now first step. So I hope that you still remember. Okay, the first step is you need to check whether this function is odd or even. Okay, this function is odd or even. Okay, so this is your function, and okay, what I said before, if you have a modulus here means that this function actually is not a single function, it's a two function. So what we need to do is we make it into two. So the first part is negative and the second one is a positive. Alright, for the negative one is with the interval will be start from -1 x until 0, and for the positive part is from 0 x until 1. So you can see that this interval is continuity lah. I mean it's from -1 to 0 and then continue from 0 to 1. So we will get the original interval back. Okay, alright, so this is your interval. Okay, or your function, sorry. So how we want to check, okay, which method or which way that we want to consider to check whether the function is odd or even. Either you want to use equation or you want to use a graph. So for this case, okay, for the piecewise function, or means that you have more than one function, I prefer you to use graphical. Graphical is more easiest. Okay, graphical is more easier for you to check whether this function is odd or even. Okay, so this is your function. This is your graph. So you will plot two lines here. First line is negative x. The second line is a positive x, right? So okay, for the first one, negative x. Okay, how the graph of negative x? How the graph of negative x? Okay, okay. Let's say we do it for this one. How the graph of x, y equal to x? How the graph of y equal to x looks like? Yeah, it's a straight line, right? It's a straight line. So you need to start from 0. You follow this interval. So you need to start from 0 and then you will stop at 1. Okay, so we consider this is the line for x. Okay, so how about negative x? How about negative x? So this is negative x. Okay, if x is naik lah kan, naik, so negative x will be downwards. Okay, downwards. So still it start from 0 and it will be end in -1. Okay, so this is the graph of modulus x looks like. Okay, now based on this graph, can you conclude whether this function is odd or even? Okay, for odd, I repeat, for odd it must symmetry about origin, and for even it must symmetry on y-axis. So if you can see clearly that this is what we call is asymmetrical on y-axis, therefore this function is even. This function is even. So then we proceed to step number 2. Okay, like I said before, step number 2, we need to know after we know that the function is odd or even. So then the Fourier coefficient. Okay, we have a0, we have an, and we have bn. Since this is an even, your bn will be 0. Okay, bear in your mind, if the function is odd, okay, like the previous example that we do is odd, right? So therefore your a0 and your an are zeros. Now this equation, this example, the function is even, so therefore your bn is 0. Okay, a0, an, and bn we call it as a Fourier coefficient. Okay, so step number 2 settle here. What we do next is you can write your equation first. Okay, your Fourier series equation is fx a0 over 2 plus summation of n from 1 infinity, and then inside here, okay, saya turun ke bawah lah, ada space sikit. Alright, so an cos n by x over L plus bn sine n pi x over l, is it? So since your since your bn is 0, so therefore they have no, this term will be equal to 0 because bn already 0, so therefore this term is already limited. Okay, so you left with, okay, I will erase this one. Okay, I will erase this one. So you will left with a0 over 2 plus summation of n1 infinity. Inside the bracket you have a n cos n pi x over l. So now your job is to find a0 and also an. Okay, what is your a0? Okay, so like I said before in the previous video, we have two types of formula for a0, an, and bn, right? So which formula that we want to consider for this one? You need to refer to your function. I already give you example function 1, 2, and 3. So when you have a single function, which type will you choose? When you have a piecewise function, which type will you choose? So for this one, you will choose the first type, right? You will choose the 1 over L. Negative L, okay, fx dx. Okay, you will choose the first type, which is 1 over L. Okay, so now fill up what is your L. So you can guide your L from the interval. So your interval is negative 1, 1, 1. So means that the L is 1. So therefore, I just write 1. Okay, 1 over 1, right? Okay, this is your L. So I don't want to make it complicated like that because it's 1 over 1. So just write 1. Alright, so here is negative 1 until 1. And then your function, okay, your function is actually is modulus x, right? Okay, so careful. Kat sini ada something that you need to make it. Ada something lah. Okay, right. From here, and then from this modulus x, remember you already bracket this function become 2, negative and also the positive, right? So what we do next is, okay, I will back to this part. Okay, okay, give me time. Alright, okay, then what we do next is, okay, we continue here. Alright, so you will integrate 1. Integrate negative. Okay, 1 pun tak tulis lah. Alright. Negative, just now is 1, negative 1, right? So your function is modulus x. Okay, from here, you need to, because your function is now, they have two function. Okay, saya dah padam, so you can refer to the next video. Sorry, you scroll back. Okay, backward balik, tengok video tadi. Alright, so what we do next is, you need to start from negative 1, of course. But you will end here 0. Okay, and then what is the function here? This function will be negative x. Okay, if you can refer back to your function, the interval from negative 1, 0, your function is negative x. Okay, and then plus from 0 until 1. And then here is positive x. Okay, so then just solve this integral. So you will get the answer is, okay, saya tunjuk lah. Okay, right, so negative x square over 2, substitute here, this one is x square over 2, substitute 0, 1 also, so you have 0, negative 1 over 2, negative 1 over 2 plus 1 over 2, so you get 1. Okay, right, so the answer for a0 is 1. Okay, this one baru a0. So now the next one is you need to solve, or you need to find your an. Okay, find out your an. Okay, find out your an. So your an also you do it the same thing. Okay, from, okay, here is 1, right, but okay, boleh lah nak tulis pun. Right, so start from negative 1 also. Negative 1, 0. The function is negative x, but you have extra, right? You have a cos n pi x over L. Whereas your L is 1. Okay, so saya tak tulis. Okay, right? Plus 0, 1, positive x cos n pi x. Okay, with respect to dx, eh? So, how to solve this one? You need to use a tabular method. Okay, why tabular method? Because they have two x here. Okay, they have 2s here, so that's means you need to use a tabular method. So you do it your tabular method by yourself, and then your answer would be, okay, I give you answer, then you can check whether it's correct or not. I mean, check your answer with this. Okay, you will get this one. Okay, sorry. N by 2 negative 1 power n minus 1. So this is the answer for AN. Okay, so next, I tak ingat step berapa dah, step 3 ke step 4. Alright, next what we do is, you already get the value for A0 and N, right? So you just substitute back into this formula. Okay, substitute back into this formula. What is your A0, what is your N? So the final answer is 1/2 plus summation n1 infinity, and your an just now is 2, n pi square, in the bracket they have negative 1 power of n minus 1, and then cos n pi x. So this is the final answer. Okay, alright, okay.